Matthew Harvey, Gracie Hurley, and Rebecca Robbins will be constructing a map by primitive means using pace length to measure distance and Adelaide to measure angles. This will map out the bend in the Charles River between the Elliott Bridge and the Anderson Memorial Bridge.
Our hypothesis is that we can map out the bend in the Charles River using an alidade and pace length within 25 feet of accuracy.
The alidade is a primitive instrument used to measure angles between sighted objects. It consists of a flat plane surface and a bar that rotates around a pivot point at the center of the base. On top of the base lies this 360-degree circular chart marked with degree intervals. An alidade can be found on the back of other primitive instruments, such as the astrolabe.
This instrument is an instrument used in conjunction with the alidade is the theodolite. Attached to the alidade is a telescope which rotates around the alidade. The telescope rotates north and south to determine the angular height of stars from the horizon, and rotates around the alidade to determine the angular measurement between sighted stars.
Originally, the alidade was a simple ruler-shaped object with a sighted marker attached to each end. As the alidade developed, it was attached to a graduated circle marked with degrees. This allowed the measurer to set the alidade in a horizontal plane and measure the angle between sighted objects with greater precision.
That alidade was used in conjunction with baselines of known length to establish a control network of points running along one edge of the area to be mapped. The alidade is then used to sight objects at each of the control points, which allows for the finding of specific objects by triangulation.
Methods. We constructed our own alidade by purchasing a round wooden base, a 3/8 of an inch square dowel, and printing a 360-degree graduated circle. We taped the circle to the base and nailed down the dowel to the base in the center, and then nailed 2 nails at the ends of the dowels for sighting markers.
Our sightings began at the southwest corner of the Anderson Memorial Bridge on JFK Street. Our first step was to find true north with a magnetic compass. Next, we oriented the alidade with the northing on the compass. Finally, we rotated the dowel on the alidade to line up with distant objects and find the angular measurements to those objects.
To move between locations, Matthew and Gracie counted their paces and took the feet to pace ratio found in the first assignment to find the distance between sighting locations. These two values were averaged to get one measurement of feet between objects. We chose this method instead of measuring with a rope or chain marked with set intervals because there were many obstacles in between our sighting locations. Rope measurement between sightings would not have been possible.
We continued west in this manner along the south bank of the Charles River. Our last measurement was taken across from the Belmont Hill and Windsor Boathouse. We then transferred our measurements to a graph paper map on course of the Charles River.
After constructing our map, we compared our map to a Google Earth map, measuring the differences in distance between sighting locations and the differences between angles we measured and the actual angles from sighting locations, after converting these into northing and easting measurements.
Results. In our final draft of our project, we will submit results analyzing how accurate our measurements were compared to the ones used in Google Earth.